Hello everyone, this is Kalpana here. In this video, we are going to see a problem from partial differential equation. So let's get going. Problem: form partial differential equation by eliminating the arbitrary constants from a relation 4z of 1 plus a square equal to x plus ay plus b whole square. Well, we are given an equation or a relation 4z of 1 plus a square equal to x plus ay plus b square, right? 4z into 1 plus a square equal to x plus ay plus b square. Consider as equation 1. We are asked to form a partial differential equation by eliminating the arbitrary constants a and b from this equation. So we'll see in two ways. Firstly, I'll go with the long process in detailed way, and finally we'll see the shortcut just by decreasing the number of steps. Okay, fine. Now let's partially differentiate the given equation with respect to x. Apply dou by dou x on both sides of 1. See here, z is a function of x and y, or we can say z is a dependent variable, and where x and y are independent variables. Right? Here 1 plus a square is treated as constant, right? And also 4 is constant. We can write it as into dou by dou x of z, right? Equal to, just expand x plus ay plus b whole square here itself. We can just expand x plus ay plus b whole square at the beginning itself. Better, let's expand it. Okay, I am expanding it using a plus b plus c whole square formula, which is equal to a square plus b square plus c square plus 2ab plus 2bc plus 2ca. We'll get x square plus a square y square plus b square plus 2xay or 2axy plus 2aby plus 2xb plus 2bx otherwise. Consider as equation 1. Okay, now let's partially differentiate one with respect to x. Partially differentiating one with respect to x. Let's apply dou by dou x on both sides of 1. Since we are partially differentiating with respect to x, so y will be treated as constant here. This gives us 4 into 1 plus a square into partial derivative of z with respect to x, dou z by dou x equal to partial derivative of x square with respect to x is 2x, partial derivative of first term plus partial derivative of second term plus partial derivative of third term, fourth term now, last but one, last one. Okay, fine. This gives us 4 times 1 plus a square into, since we have a notation dou z by dou x equal to p, let's replace it by p. You'll get into p equal to Partial derivative of x square with respect to x is 2x plus partial derivative of a constant with respect to x is 0. Since we are partially differentiating with respect to x, so we'll treat y as constant. Here a square and y square is treated as constant. So partial derivative of constant with respect to y will be 0. Plus partial derivative of a constant with respect to x is 0. Plus partial derivative of here 2ay is treated as constant. Let's write 2ay into dou by dou x of x plus partial derivative of constant with respect to x is 0 plus here 2b is constant. Let's write it as 2b into partial derivative of x with respect to x. This gives us 4 times 1 plus a square into p equal to 2x plus 2ay into partial derivative of x with respect to x is 1 plus 2b into partial derivative of x with respect to x is 1, right? Which gives us 4 times or 4p into 1 plus a square equal to 2x plus 2ay plus 2b. We can take 2 common from all the 3 terms of RHS, then you'll get 4 into p into 1 plus a square equal to 2 times x plus ay plus b, right? Now bring this 2 to LHS, you'll get 4p into 1 plus a square by 2 equal to x plus ay plus b, right? Which gives us 2p into 1 plus a square equal to x plus ay plus b, or we can write this as x plus ay plus b equal to 2p into 1 plus a square. Consider it as equation number 2. Okay, by partially differentiating one with respect to x, we will get equation 2, x plus ay plus b equal to 2b times 1 plus a square, right? Now let's partially differentiate 1 with respect to y. Partially differentiating 1 with respect to y. Okay, just apply dou by dou y on both sides of 1. Since we are partially differentiating with respect to y, so we'll treat x as constant. Right? This gives us constant 4 into 1 plus a square into dou z by dou y equal to partial derivative of x square first term, partial derivative of second term, plus partial derivative of third term, plus partial derivative of fourth term, plus partial derivative of last but one, plus partial derivative of last one, right? Since we have a notation dou z by dou y equal to q, so we'll replace it by q. You'll get 4 times 1 plus a square into q equal to partial derivative of a constant with respect to y is 0. Since we are partially differentiating with respect to y, so we'll treat x as constant. So here x square is also treated as constant and the partial derivative of a constant with respect to y will be 0, right? Plus a square constant into partial derivative of y square with respect to y plus partial derivative of a constant with respect to y is 0 plus constant 2ax into partial derivative of y with respect to y plus constant 2ab into partial derivative of y with respect to y plus partial derivative of a constant with respect to y 0. This gives us 4q into 1 plus a square equal to a square into partial derivative of y square with respect to y is 2y plus 2ax into partial derivative of y with respect to y is 1 plus 2ab into partial derivative of y with respect to y is 1. This gives us 4q times 1 plus a square equal to 2a square y plus 2x plus 2ab. Here, if we observe, we can take 2a from all these three terms, right? Which gives us 2a times ay plus x plus b. Bring this 2a to LHS, you'll get 4q of 1 plus a square, 4q into 1 plus a square by 2a equal to, we can write the terms under brackets as x plus ay plus b, right? 2 gets cancelled, you will get 2q of 1 plus a square by a, that is 2q into 1 plus a square by a equal to x plus ay plus b, or we can write this as x plus ay plus b equal to 2q times 1 plus a square by a. Consider it as equation number 3. Right? Now observe 1, 2 and 3, or the given equation 2 and 3. So it is clear that by substituting 2 or 3 in 1 or the given equation, the arbitrary constants a and b won't get eliminated, right? So now observe 2 and 3. By observing 2 and 3, we can say that we can equate these two, since x plus ay plus b equal to that term and x plus ay plus b equal to 2q times 1 plus a square by a, right? So we can equate these two. Now using 2 and 3, from 2 and 3 we get 2b times 1 plus a square equal to 2q times 1 plus a square by a. We can just cancel 2 and 1 plus a square from these two, right? Or just take 1 plus a square and 2 to RHS, you'll get this a into 2 into 1 plus a square, right? Where 1 plus a square and 2 gets cancelled, and you'll get p equal to q by a. From this, you'll get a equal to q by b, right? Therefore, a equal to q by b. Now substitute the value of a in any of these two equations, okay? Either in either in 2 or in 3 to find b. So I'll try with 2. We have 2 x plus ay plus b equal to 2b times 1 plus a square. Now substitute a equal to q by p. You'll have x equal to, you'll get q by p plus b equal to 2p times 1 plus q square by p square, which gives us x plus q by p into y plus b equal to 2p plus 2p q square by p square, which gives us x plus q by p into y plus b equal to 2p plus 1p gets cancelled, then you'll get 2q square by p. Now take these two terms to RHS, you'll get b equal to 2p plus 2q square by p minus x minus q by p into y. So we got b. Likewise, let's try for 3 also, equation 3. We have 3 x plus ay plus b equal to 2q times 1 plus a square by a, right? Now substitute a equal to q by p. We'll get x plus q by p into y plus b equal to 2q by p into 1 plus q square by p square, which gives us x plus q by p into y plus b equal to 2qp by q into 1 plus q square by p square, where 1q gets cancelled here, and which gives us 2p into 1 2p plus 2p into this term 2p q square by p, where 1p gets cancelled. Now take these two terms to RHS, you'll get b equal to 2p plus 2q square by p minus x minus q by p into y. You'll get the same thing, right? Now we are having a and b. Let's substitute a and b in the given equation. Now substitute a, b values in given equation. We have given equation 4z of 4z into 1 plus a square equal to x plus ay plus b whole square, right? Substitute the values of a and b. We get 4z times 1 plus, we have a q by p whole square equal to x plus a q by p into y plus b, 2p plus 2q square by p minus x minus q by p into y whole square. It's not z, it's square, okay? Fine. Which gives us 4z times 1 plus q square by p square equal to x plus q by p into y plus 2p plus 2q square by p minus x minus q by p into y. Here plus q by p into y minus q by p into y gets cancelled, plus x minus x gets cancelled. This gives us 4z times p square plus q square by p square equal to 2p plus 2q square by p. Here you'll be having square, whole square, right? Now let's split this as 4z times p square plus q square by p square equal to 2p into p, 2p square plus 2q square by p whole square, which gives us 4z times p square plus q square by p square equal to, take 2 common from these two terms, you'll get 2 times p square plus q square by p whole square. And we can write this as 2 times p square plus q square whole square by p square, right? Which gives us, you can just cancel p square, this p square, right, from LHS and RHS, or just take this to RHS, then you'll get 4z times p square plus q square equal to p square times 2 times p square plus q square whole square can be written as 2 square, which is 4, into p square plus q square whole square by this p square. Okay, p square gets cancelled, and also you can take this 4 to RHS directly. Okay, in the next step we can take 4 common or just cancel here itself, which gives us 4z times p square plus q square equal to, here you're having square, okay, p square plus q square whole square, 4 times p square plus q square whole square. Now in the next step you can take 4 times p square plus q square to RHS. Okay, we can write this as z equal to 4 times p square plus q square whole square by 4 times p square plus q square, where 1 p square plus q square gets cancelled and this 4 gets cancelled, which gives us z equal to p square plus q square. See, it does not involve any arbitrary constants. Therefore, z equal to p square plus q square is the required partial differential equation. And also, finally, we got an equation of the form say f of zpq equal to 0. Okay, it does not involve any arbitrary constants. Okay, an equation of this form, we can get an equation of this form, which is called a partial differential equation. It involves z, p and q, and this does not has any arbitrary constants a and b here. Fine. So we got a partial differential equation z equal to p square plus q square. Right. Now let's see the shortcut just by decreasing the number of steps. See, we wrote the given equation by expanding the RHS part using a plus b plus c whole square formula, right? Now let's partially differentiate it with respect to x and y. We'll just use the shortcut partially differentiating 1 with respect to x. Okay, we'll get 4 times 1 plus a square into dou z by dou x equal to partial derivative of x square with respect to x is 2x plus partial derivative of a constant 0 plus partial derivative of a constant 0 plus 2ay into partial derivative of x with respect to x is 1 plus partial derivative of a constant 0 plus partial derivative of x with respect to x is 1, right? Since we have a notation dou z by dou x equal to p, let's replace it by p. You'll get 4p into 1 plus a square equal to 2x plus 2ay plus 2b, where you're having 2 in all the 3 terms of RHS, so we'll take it common from all those terms. We'll get 2 times x plus ay plus b, right? 2 ones are 2 2s are, which gives us 2p of 2p times 1 plus a square equal to x plus ay plus b, or we can write this as x plus ay plus b equal to 2p times 1 plus a square, which we have considered as equation number 2. Now let's partially differentiate 1 with respect to y. Okay, 4 into 1 plus a square into dou z by dou y equal to partial derivative of x square 0 plus a square into partial derivative of y square with respect to y is 2y plus partial derivative of b square with respect to y is 0 plus 2ax into partial derivative of y with respect to y 1 plus 2ab into partial derivative of y with respect to y 1 plus partial derivative of a constant with respect to y 0. Since we have a notation dou z by dou y equal to q, so we'll replace it by q, which gives us 4q times 1 plus a square equal to 2a square y plus 2ax plus 2ab. Now, take 2a common from all these 3 terms. We'll get 4q times 1 plus a square equal to 2a times ay plus x plus b. 2 2s are, we'll get 2q times 1 plus a square. Bring this a to LHS, we'll get 2q times 1 plus a square by this a equal to, we can write this as x plus ay plus b, or x plus ay by b, plus b equal to 2q times 1 plus a square by a, which is considered as equation number 3, right? Now As I said earlier, we cannot substitute 2 or 3 in 1 because in 1 or in the given differential equation, because by replacing this term by 2b times 1 plus a square or this term by this using equation 3, the arbitrary constants won't get eliminated, right? Okay, so we'll just use 2 and 3. Okay, by 2 and 3, from 2 and 3 we get 2p times 1 plus a square equal to 2q times 1 plus a square by a, where 2 and 1 plus a square gets cancelled, and you'll get p equal to q by a or a equal to q by p. Now just substitute this in any of these two equations. I'll go for 2. We have equation 2, that is x plus ay plus b equal to 2p times 1 plus a square. I'll just substitute the value of a here. We'll get x plus q by p into y plus b equal to 2p times 1 plus q square by p square, which gives us x plus q by p into y plus b equal to 2p plus 2p q square by p square, where 1p gets cancelled, and we'll get x plus q by p into y plus b equal to 2p plus 2q square by p. Okay, now just take these two terms to RHS, then you'll get b. Then b equal to 2p plus 2q square by p minus x minus q by p into y is our b. Okay, 2p plus 2q square by p minus x minus q by p into y. Now we got a and b. Let's substitute this in the given equation. We have 4z times 1 plus a square equal to x plus ay plus b whole square. Now just substitute the values of a and b. We'll get 4z into 1 plus a square, that is q square by p square, equal to x plus q by p into y plus b is 2p plus 2q square by p minus x minus q by p into y whole square, where minus q by p into y plus q by p into y gets cancelled, plus x minus x gets cancelled, and this gives us 4z times p square plus q square by p square equal to 2p plus 2q square by p whole square. Okay, you can write this as 4z into p square plus q square by p square equal to 2p into p, 2p square plus 2q square by p whole square, which gives us 4z times p square plus q square by p square equal to, just take 2 common from these two terms, you'll get 2 times p square plus q square whole square by p square, where p square gets cancelled, and you'll get 4z times p square plus q square equal to 2 square, 4 into p square plus q square whole square, right? 1 p square plus q square gets cancelled, and this 4 gets cancelled. From this you'll get z equal to p square plus q square, which is a required partial differential equation. So it does not involve any arbitrary constants, right? This completes the problem. Well, we have seen a problem from partial differential equation in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.